Good afternoon and welcome to our today's lesson, that is the Ambassador Speaks Lessons. We have not had lessons for the last 1 week because I was held up somewhere. I was with some other things. That one doesn't mean that you are of less importance. No, you are very important people. So I'm back again, and this time around I'm discussing chemistry. And like as I posted earlier, and as you can see on my description there, I'm discussing chemical families, and to be very specific, alkali metals. So if you're new to this channel, I invite also others, so that we can discuss as many things as possible. We discuss physics, we discuss chemistry, we discuss other subjects, we also discuss life issues, we discuss academic talks, and very many things, including career-wise. So the person who is in the lesson, just confirm to me that you can hear me, so that I can get the confidence to proceed. If you can hear me, I just want one word that teacher, we can hear you. I'm Sir Alex. Depender, call me Ambassador. So, who can confirm to me that you can hear me? Who can confirm that I'm very audible? I'm taking a minute as I'm waiting for you. Who can confirm that I'm audible? Somebody there? Yes, I'm waiting for someone to confirm to me that I'm audible and you can hear me very well, so that we can proceed. And you can also tell me where you're watching me from. And so you have your notes on chemical family, so that we can use them in this lesson. So, okay, Angela Diana is saying that I'm very audible. Thank you, Angela, for that clarification. So, I'm online in 2 channels, or in 3 actually: Mickey Slate Media, Ambassador Speaks, and Shifting Grades. So, in all cases, ensure you stick to our lessons every day. What I was going through, my videographer was somewhere coming. Mickey, kuja hivi. Fika tu utanipata nikiproceed to kuja ufanye some settings kidogo. Nasema kama tu utapata nikiproceed ndio kuja. Sawa. Sorry for that, I was communicating to somebody great in my team. Can we start now? Can we start? Are you ready to start? Yes, so Timothy is saying that I'm audible enough. Thank you for that. Now, I want to talk about chemical families. The first topic in Form 2 is structure of the atom and the periodic table. Structure of the atom and the periodic table. So we learn about very many elements. Yes, the first 20 elements. But now, these elements are placed in various groups. These groups are called chemical families. Like right now, if we have to classify, ama ukipewa watu wa family fulani, wajue these people ni wa family fulani, hawa ni wa familia ingine, wale ni wa familia ingine, you will realize that while of family fulani, all of them may be tall, or all of them may be short like me, or all of them may be black, or they may be chocolate like me. I mean, you will know this one belongs to a certain family. Anyway, in our families, kuna kuanga na yule mtu anakuanga very short kwa wengine wote. And in most cases anakuanga firstborn, you know, wanakuanga na shida gani? Wanakuanga shortest of all the members. No problem about that. Now, in elements, if we place elements that reacts in the same way, that has the same chemical properties and physical properties, if we put them together, we will call them a chemical family, or they will form a chemical family. So we have the following chemical families. We have the first one called alkali metals, the one that I'm supposed to discuss today. The second one, we have alkaline earth metals, is another chemical family. The third one, we have group 3, but what we are supposed to study in this topic are only 4 alkali metals, which is group 1 elements, alkaline earth metals, which is group 2, halogens, which is group 7, then noble gases, which is group 8. Are we together up to that point? Yes, but for today, we are only dealing with one, alkali metals, which I would like us to start it right now. And if you have to write notes, please write it very fast, but no need to write them because you have them. That's why make sure you have the notes. So good. So alkali metals. To answer the members. What are the members of alkali metals? We have 3 main members. The rest you will research for yourself for your own benefit. Now we have lithium, we have sodium, and we have potassium. Those are the 3. That was my technician doing his things there. Now, see whether the boat is visible. So I said we have the first 3 members. We have lithium, we have sodium, we have potassium, alkali metals. Remember, when I was teaching the other day, I said this. In group 1, nikisema group 1, hapa tunaanzanga na hydrogen. But when we say alkali metals, hydrogen is not a member of alkali metals, but hydrogen is a member of group 1 elements. I don't know whether you are getting me. Group 1 elements include hydrogen. Alkali metals, which is the chemical name of group 1 elements, does not include hydrogen, because we all know that hydrogen is not a metal. Are you together? Welcome. You're saying that you can't see me. Why Beverly? Beverly? You talking now? Yes, I think now everything is going on well. We've missed the lesson for so long, like don't worry about that. I'm back now. And every day at 3 p.m., 8 physics and chemistry, but we are on. Ambassador will always be there for you. So we were looking at the 3 members. I hope now you have understood why hydrogen is a member of group 1 elements, but hydrogen is not a member of alkali metals. What removed hydrogen is the word metals. Hydrogen is a non-metal, and in fact, it's a gas. Now, these elements, which are group 1, the other day we learned about electronic configuration. What did we say about electronic configuration? We say that it is the arrangement of the electrons. Now, this one has 2, 1. Sodium has 2:8:1, and potassium has 2:8:8:1. So the common thing about all of them is the outermost energy levels. It is 1, 1, 1, group 1 alkali metals. That is the first thing I would like you to know. About electronic configuration, kama uko na issue about electronic configuration, I would advise you refer to our former videos which I have taught about the same. Just check on how we discussed topic 1, structure of the atom and the periodic table, and you will see how we came up to say that lithium is 2:1, sodium is 2:8:1, potassium is 2:8:8:1. These ones are derived from the atomic numbers. Well, now, after knowing that, we are supposed to learn about comparison of the atomic size of these particular elements. In a group, we move downwards this way. So at this point, allow me to remove this hydrogen because I say it's not part of the alkali metals. So we have sodium, we have lithium, we have sodium, then we have potassium here. Somebody will tell you, giving reasons, give the gradation or explain how does the size of these atoms varies. And for all the groups, or in all the groups, one thing that you need to know is this. The atomic size always increases down the group. You don't stop there, you explain why. Yes. You don't stop there, you have to explain why the atomic size increases down the group. If you ask, the good thing is all the groups, they have the same explanation. As you move down the group, the number of energy levels increases, which increases the size of the atom. Very simple, look at this. Lithium has 2 energy levels. The first one is the one occupied by 2. The second one is the one occupied by 1. So it has 2 energy levels. Sodium on the other hand has 3, and potassium on the other hand has 4 energy levels. So that is the reason why they increase down the group. Mpaka hapo tuko pamoja, si ndio? Tumeelewa hapo kuna points mbili. And by the way, there are 2 categories of examiners. The first examiner atakuuliza state and explain how the size of the atom varies down the group 1. So hapo itabidi akupe either 1 mark in each case, ama akupe half in each case upate 1 mark, ama 1 upate 2. Then kuna examiner mwenye atakwambia it is observed that the atomic size in group 1 or in alkali metals increases down the group. Explain. Hapo atakupea half a mark ama akupatie 1 mark. It's either to increase or to decrease. So unajua tunasemanga kama mtu ameshindwa kujibu umemuuliza kama ina increase ama ina decrease. Wanasema nini? Eunice anasema kazi. The size does what? So I send on live. Now, after knowing that, now you are free to go. We can check on something else. And let's go for swali about the atomic size. Let me check on that side kama kuna swali. So there's no question on the side of the shifting rates. Now let me proceed here. So that is good. Niko na swali hapa na kila mtu ajipange kujibu swali. Hii nimeongelelea ni atomic size. What about ionic size? What about ionic size? So tumeona atomic size increases down the group because of the increase in the number of occupied energy levels. That is the atom. What about ion? For example, lithium ion has 1 energy level. Sodium ion has 2 energy levels. Potassium ion has 3 energy levels. Why? E ni atom. 2888:1 is the atom. This is the ion. This is the atom of sodium, 2,1, but 28 is the ion. And 2,1 is the atom for lithium, but 2 is the ion for lithium. So even if we base on the issue of ionic size, then it will still increase because lithium ion has 1 energy level, sodium ion has 2, potassium ion has 3. So it increases down the group. You can see and I can also see. So that is the same thing. Both ionic and atomic size increases down the group. Right together? Because each alkali as you move down has an extra energy level. Hapo tuko sawa? Now, kuna kitu fulani ndaka niseme so that we can proceed. Okay, I'm asking a question so that those who knows can drop it on the comment section. Compare the atomic and ionic size of alkali metals. Compare the atomic size and ionic size of alkali metals. In short, I'm asking, for example, sodium. Sodium atom and sodium ion, which one is the greater? Yeah, it's one or two. Between atomic size and ionic size of alkali metals, which one is larger and which one is smaller? In short, I'm saying compare. I'm waiting for your answer. Pale kwa chat box. I'm cleaning the board to give you time to type. Yes. Nione kama kuna mtu yani kinandida amwezi mkajibu hiyo swali. So let me check on the other side. Isaac is asking what is an atom. Okay, so Isaac, please refer to our lessons that we taught last week, part 1, to discuss our topic fully on structure of the atom and the periodic table. We actually define all those terms, but don't worry, we will define the term atom before the lesson ends. Sheila Wanyonyi is saying that atomic size is greater than ionic size. Atomic size is greater than ionic size. Can you give reasons, Sheila? Can you give reasons? Beverly, Timothy, and Dinda, together with Eunice. Oh, sorry, Eunice and Dinda. Can you give that? Now look here. Let's compare sodium atom. You're gonna 2:8:1. Then sodium ion. You see the difference between sodium atom and sodium ion, right? It has 2:8. So this one has 3 energy levels, 3 occupied energy levels. This one has only 2. So between sodium ion and sodium atom, which one is large? Of course, sodium atom is larger than the sodium ion. And the reason is what I've just said. Because sodium atom is having more occupied energy levels. Kidogo tu, out of the topic, let's compare for chlorine and for chlorine ion. Good. Can we compare the atomic size of chlorine size? Very fast, kidogo. I'm waiting for you. Adams Ntoroga anasema next I cover what you call organic chem. It will be covered before the end of the holiday. It will be covered. But right this week I want to clear it from to work, and maybe part of next week. But I've been covering moles. I've covered moles. I will cover gas loss, then the organic. So keep on following either the shifting grades or Ambassador Speaks or the Mickey Slate Media. Those three, as I have said, are our channels that we use to teach. Yes, I'm waiting for the answer between atomic size, chlorine and its ion size. Which one is larger? Yes, and I'm just waiting for you. Mtumada akijibu ndio nitajibu. Sheila anasema ionic size is larger. Let me explain. Let me explain this, and please get it very clear. Chlorine atom is having 2:8:7. Chlorine ion is having 2:8:8.